Hi everyone, welcome back. So we're going to take a look at this additional example that we didn't get to on the last video. So this is not in the guided notes. I'd suggest that you write it down somewhere because you are going to see some natural logarithms and also some common logarithms that we talked about at the beginning of the first video, part 1. So if we want to graph negative ln of x minus 1 plus 2, we want to first identify, same steps here, the parent function and the inverse parent function. So the parent function, if we remove all the things being added, subtracted, and multiplied to this logarithmic function, we just have plain old natural log of x. And if you recall, the natural log of x is what we call the natural logarithm. And the natural logarithm is assumed to have a base e. So its inverse parent function is e to the x. And we know from our exponential function video notes and from our classwork, e to the x has 3 key points. Again, you can always graph more than 3, but our 3 key points, e to the negative 1 is 1 over e to the first. And since e is about 2.72, 1 divided by 2.72 is about 0.3679. And e to the 0 is 1. And e to the first is, the number e, which again, here's its approximation. You can round it to the 100th, that's fine, just like you do when you round pi to 3.14, even though we know pi is a non-terminating decimal and it's an irrational number. So its logarithmic parent function is log base e of x, which is what they condense down to ln of x. And so if we know the ordered pairs for e to the x, then we know that the natural log of x has the reverse of those because they are inverse functions. So the x's and y's will switch. And so now we have these 3 new ordered pairs, and kind of looking at our main non-decimal number here, we have an x-intercept sitting at 1. And then we want to describe the transformations in the proper order of the logarithmic function we're trying to graph. So this minus 1 is moving your graph right 1. The negative is causing a reflection across the x-axis, and the plus 2 is moving your graph up 2 units. So we're going to have to use the log base e of x, or this natural log of x blue table here, these 3 key points, and the transformations in the proper order to move those 3 key points to obtain our new graph of g of x. So if we look at our x-intercept at 1, 0, this is probably an easier point to see. We're going to go right 1 unit, and then we're going to reflect across the x-axis. Well, now we're sitting on the x-axis, so we can't flip across the x-axis, and then we move up 2. So now we have the ordered pair 2, 2. If I take this decimal value of 2.721 and I move right 1, I'm now at 3.721. And then if I reflect across the x-axis, I'm now sitting in the negatives. And then if I move up 2 units, I'm now sitting here on this graph in black. So this graph sketched in black is your function negative ln of x minus 1 plus 2. Just be careful graphing the decimals, just approximate them. Really, you can see I really only wanted to indicate this one main point of 2, 2. And you can give a sketch through the decimals because the integer ordered pairs are going to be easier for you to sketch. So the domain. We can do this algebraically like we talked about in part 1 of the video, where x minus 1, what you're taking the logarithm of, has to be greater than 0. So if I add 1, x has to be greater than 1, which means, and you can see graphically, your graph is approaching 1 and going to the right off to infinity, but it's not ever going to reach 1. So 1 is not included or in a parenthesis. The range of every logarithmic function is all real numbers, or negative infinity to positive infinity. And your vertical asymptote has to do with your domain as well. So if you're approaching 1 but not reaching 1 on the x-axis, then your vertical asymptote is at x equals 1. You can also think of it as a transformation. So if your parent function has a vertical asymptote at 0 and you move right 1 unit, your vertical asymptote is now sitting at x equals 1. So hopefully this additional example helped you just so that you could see kind of those logarithms that don't have the subscripts. You do the same exact process, you just need to understand that a natural logarithm, ln of x, is log base e of x, and log x is log base 10 of x, which we call a common logarithm. All the other logarithms will have a subscript indicating the base if it's not base 10 or e. The others are assumed, and that's something you need to know. So what I'd like you to do now is complete some of the example practice problems for homework that kind of tag along with this video as well, and then we can go over any questions you have in class tomorrow. Hope you're all well. Thank you.